In this video, we're going to take a quick look at strings in Java. Now, I emphasize a relatively quick look. We're going to see what strings can do in Java, but remember we're going around the carousel twice. So first of all, we're just going to take a sampling of what things can do, which is what we're doing in this video. And then in a future series of videos, we'll take a look at some more string operations like substrings, index of, car@, and several other methods. Not for this video, but that will come in the future. So what are we going to discuss? First of all, what a string literal is. Secondly, what string immutability means. Then we'll talk about concatenations in the string builder. We'll take a look at the size of a string, and we'll consider what final means, what static means, and in likely a separate video, we'll take a look at an array. So number one, why are strings important? Well, these days you hear a lot about JSON data, and JSON is an easy way for us to integrate data onto a mobile platform. That's very important because many times a mobile app is taking data from different sources and making information out of it. So here you see some JSON data that is describing oak trees. If I were to put in pine, we'd see some data that describes pine trees. So this is what we call a JSON format, and if you take a look at here, you may or may not find this to be readable, but you can see some patterns that are evolving where we have an ID and a value, a genus and a value, and a species and a value. And as we look down, essentially every line represents a plant, and that plant's ID, genus, species, cultivar, and common. So to actually make some use out of this data, we have to understand what a string is. Now, one more note on this JSON data. Open data is becoming very popular now, especially among cities. And this is where you can look at things like crime statistics and also health ratings for restaurants, things like that, using a very similar format to the one that I have here. So with that as a backdrop, let's take a look at strings and how we use them in the Java programming language. This is the vehicles program that we've been editing so far in this class. And if we take a look here, we'll see that we have a string literal right here. And what do we mean by string literal? A series of characters that are enclosed within double quotes. So you see, we've declared this string exactly where we're using it, which is where we're prompting the user, how many miles per gallon does the vehicle get? Now, if I wanted, I could take this string literal, I could remove it from this method call. Notice that show input dialog is actually a method that we're calling. You may or may not have noticed that before, but that's what's going on. Let's say I highlight this string, which is enclosed in quotes. I control X, and then I make a new line where I say string mpg prompt equals, and then paste, terminate with a semicolon. Now on the line below where I used to have the string literal, I'll replace it with mpg prompt, which is the variable I've declared up above. And you see we're back to a compiling state, and the program works as it always has worked. As a matter of fact, I can go ahead and run it, and we can confirm that the first thing we're going to see is a prompt that says, how many miles per gallon does the vehicle get? And sure enough, there we go. We'll say 25 miles per gallon. Okay, how far do you want to go? 100. And then we see the output here. Gallons of gas consumed is 4.0, which is what we would expect if we drove 100 miles and we had a 25 mile per gallon vehicle. Okay, so this is a way that we can assign a value to a string variable. So take a look. Do you see that we have a variable declaration here? The variable name is msgprompt, and the variable type is string. On the right side, we are assigning a string literal to this variable msgprompt. If we wanted, we could do this in two steps. Just like so, we declare the variable on one line, and then we assign it mpg prompt rather, and then we assign it on the line down below. That's fine. There's even one more way we can declare strings, and that's by what we call calling a constructor. We could say new string and then put the string literal in quotations. That will give us the same results as we had before, just with some extra typing, so it's not really needed. In the Java programming language, if we have an assignment statement like this where we're creating a string on demand and assigning it to a variable, Java will handle all of that overhead for us of constructing a new string. One interesting thing about a string in Java, notice it has an uppercase S. It is not one of the 8 primitive types we learned about earlier. So the primitive types are byte, short, int, long, double float, char, and boolean. String is not one of those. String is kind of an object, which we might not know what an object is just yet, but it's kind of just a special thing in Java, where it's an object with some extensions to it. So that's what a string looks like. Now, if we take a look here, you see gas consumed equals plus gallons consumed, gallons remaining equals gallons of gas. That's what gave us the output down here when I ran the program. Now you see, when we have a string on one side of a plus, it's a concatenation operator, which means we're going to make a new string, which is formed by the string on the left, and then add to the end of that the string on the right. In this case, this is actually a variable, and so it's going to take the value of this variable and convert it to a string first, which kind of raises an interesting question. Take a look at double gallons of gas right here. Do you see double gallons of gas equals 10? That's very different from saying string str gallons of gas equals double quote 10, close double quote. First of all, this is a raw number type. It's going to take up a lot less space. If you remember my binary calculator that we looked at earlier, we saw that 1 byte could store up to 256 unique values for a number. But with the string, it's not looking at this as the number 10, it's looking at this as the characters 1 and 0. And with the string, using Unicode, each character alone may take up to 2 bytes. So in this case, you see that the 1 is going to take up 2 bytes, the 0 is going to take up 2 bytes as well, for a total of 4 bytes. So every character or every letter is going to take up about 2 bytes in a string, where a number type is a bit more efficient because it knows that it's going to be a number. Also notice, if the type on the left is a string, the value on the right has to be in quotes. We can't just leave it without quotes like that, because then it's going to say these types are incompatible and cannot be converted to a string. So we have to put the value in quotes if it's a string. Similarly, if we tried to put a number in quotes, that wouldn't work either, because then it thinks we're taking a string and assigning it to a number. That simply won't work well for us, so we take that back out. So a couple rules around strings there. We'll go ahead and get rid of this guy here, clean things up. One other note. To make things more efficient in the Java programming language, strings are immutable. And what that means is once we've created the string called gallons consumed, that string cannot be changed. If we try to add another string to it, we're actually going to get a brand new string that represents the sum of both of these substrings. So in other words, it's not modifying the first string, it's going to create a brand new string that represents both of these. Now, we add gallons remaining, and we're going to alter the string one more time, but remember, we can't change a string in Java just for some memory performance reasons. So what's going to happen is it's going to create a brand new string for us here again. And then once again, we have another plus, it's going to create a brand new string. So be careful in the Java programming language. When you are concatenating together a series of substrings with these pluses, it will generate a brand new parking space in memory where it's going to put those strings each time. So if you're in a loop, if you're in an iteration that can be a bit inefficient, what we oftentimes recommend as an alternative is a string builder or a string buffer. Those two are a bit more efficient, but we'll cover that on our separate trip around the carousel. A few more things we may want to consider. First of all, it's considered bad practice to hard code English text as part of your source code. It's a lot better to try to take these strings and put them into some secondary file, like a text file or an XML file, to make it easier for people to translate your program into separate languages. Also, there is a time when we want to make a constant. A constant is a variable that does not change. That could be something like the title of our program, or it could also be a root URL for something like this website where we're getting JSON data. So maybe we know that we're always going to get JSON data from plantplaces.com or plantplaces.com/Perl/mobile. It would be very inefficient if our program had plantplaces.com hard-coded in it several places. So what we might do instead is we might make a constant or a variable that does not change. In other words, the value of that variable does not change. In that case, what we'll often do is say private or public. I'll go ahead and say public final, static, string, let's say domain name. Actually, no, it should be all upper. For a constant, we use a special variable naming convention. It's all uppercase with words separated by underscores. So domain underscore name, and then we'll say equals, we'll say http www.plantplaces.com. Something like that. So you see, that's a constant that we can refer to over and over again with our program, but we see it's been defined up here. As a matter of fact, let me give it a more descriptive name. Plant places domain name. So in this case, what's our variable name? Our variable name is plant places domain name. Notice all uppercase separated by underscores, which is common, which is the naming convention we use for a constant. A constant is a variable where the value doesn't change. Final means that we cannot change this variable value to something else. Let's try it out. If I go down here to prompt user and I say plant places domain name equals foo.com. Okay. Take a look. You see red lines cannot assign a value to a final variable plant places domain name. So adding that word final means we cannot reassign this variable. We cannot assign a different value to this variable. Static, don't worry about that just yet. That just means there's only one instance over no matter how many objects we create, but we don't know what an object is yet, so don't worry about that. Public versus private just means can it be accessed from another class. So that's what we would call a constant. Those are a few extra words that you will see. A constant is essentially a read-only variable. It's something that we might see many times over in our application, and we want to define it only one place. So if we need to change it, we only change it in one place. So going back to our list, we know a string literal is a series of characters, alphanumeric characters, that are enclosed within double quotes. A string literal can be either passed to a method directly, or it can be assigned to a variable of string type. We know that strings are immutable, which means once they're created in memory, they cannot be changed. If we wish to change a string value, it actually is going to create a whole new value for us. We know that we can do concatenation with the plus operation, but it is a bit inefficient because of the immutability I mentioned above. So a string builder or a string buffer is a preferred operation, something we'll see in a future video. We know that with Unicode it takes 1 to 2 bytes per character to store a string, where an integer you could store up to 2.1 billion and use only 4 bytes. So for raw numbers, the raw number types are a bit more efficient, and they also know that you can use math. An array, we'll cover that in our next video, and I look forward to seeing you then. Thank you.